Hi class, welcome back. In this video, we're going to discuss about simple linear regression model. By the end of this topic, you should be able to write a mathematical equation that relate the dependent variable y and independent variable x. And you will also be able to draw a linear regression line, which is also known as line of best fit, interpret values of intercept and slope, and also use the equation of regression line to estimate values. Okay, so there are certain outcomes from this video. So let me show you what is a linear regression model is, class. Let's recall our previous example. We discussed about the number of hours students spent to study and their final marks, and we calculated the R and R square value. We interpret that these two variables have strong positive correlation. Do you remember? And we also, I also showed you this plot. Okay, the scatter plot for final marks and the number of hours. And from this scatter plot, we can see that the plots, okay, these dots, does imitate a linear line. Even though they are not exactly forming a straight line, but they do look like a straight line. It's like they're trying to become a straight line. So yeah, we can try to draw a straight line that can best fit all these plots. Okay, you can try to use a ruler to draw a straight line that can be as close to as much plots as possible. Kan? Even though not all plots are exactly on this straight line, but yeah, in a way you can find a straight line that can best fit this plot. So this straight line, class, is the simple linear regression model. It is the equation, is this a straight line that best represent the relationship between number of hours and final marks. So this is what is called a simple linear regression model, ataupun the line of best fit. Okay, the line that best represent the trend between your two variables. Okay, and if you recall what you learned in your secondary school, we can find the equation of this straight line. Remember, y equals to mx plus c. Yes, so if you can represent the relationship of your variable using a straight line, so this also means you can find the straight line equation to represent the relationship, to represent the linear relationship between your independent variable and dependent variable. So in this video, I'm going to teach you, okay, you're going to learn on how to find this straight line. For what? To represent, okay, the linear relationship between your independent variable and dependent variable. Okay, class? So, regression is a statistical measure that attempts to determine the strength of relationship between dependent and independent variable. Regression method describes how one variable depends on another. Simple linear regression model is a model with single independent variable that has a relationship with a response variable y, and it can be represented by an equation. So this is what we talked about just now. An equation of a straight line, or known as line of best fit. Okay. So what is the formula to get the linear equation? Okay, the straight line. In statistics, we don't really use y equals to mx plus c. Okay, the notation that we use the notation that we use for statistics for equation line, a straight line, is y equals to beta naught plus beta 1x plus exponent. So this exponent is the notation for random error component. So if you were to use a sample data to calculate the regression line, your notation will be y hat equals to beta hat naught plus beta hat 1x, in which this is actually very much similar to the one that you learned during your high school, y equals to mx plus c. Cumanya kat sini, okay, kalau kita recall balik, let's try to recall. Y equals to mx plus c. M here is the slope. Betul tak? This is the gradient. Okay, but in statistics, we don't use m, we use beta hat 1. Okay, so this beta hat 1 is also the slope. And then during high school, you learn that C here is the y-intercept, remember? This is the y-intercept. So in statistics, we use notation beta hat not as the y-intercept. And even the arrangement is also different, in which during high school, we learn that M is the first term, slope is written first, and then only the y-intercept. But in statistics, we write the y-intercept first, and then only you write down the slope and also the x. Okay, so this is the different notations, but they're basically the same thing. This is the y-intercept and this is the slope of the equation line. Okay, so in terms of the notation used in statistics, y hat is the estimated dependent variable, okay, estimated value for data y. X is the independent variable, which is data x, okay, your factor. Beta hat naught is the estimated of y-intercept, the point which the line intersects the y-axis. Okay, this is the estimated value of y when x is equals to 0, y-intercept. And beta hat 1 is the slope, the estimation of the slope of the regression line. Okay, so the formula to get slope and intercept for the one in statistics is also different from what you learned in high school, because we're going to use the data. Okay, we're going to use the sample data to calculate slope and intercept. So for slope, it is sxy divided by sxx. So this s is the same as that you calculate in our previous video. Okay, the same formula. And then for the intercept, okay, the intercept of your regression line, simple linear regression model, is beta hat naught equals to y bar minus beta hat 1 multiply x bar. Y bar here is the mean for data y. Okay, you just total up your data for y, which is your response variable, divided by sample size. And x bar here is the mean for data x. Okay, so itu je. This is mean for data y and this is mean for data x. So to practice this formula, let's use the example that we discussed in our previous class, this table here. So we're going to use this example to practice on that formula just now. So first, let's calculate the slope and y-intercept of the linear regression line, then write its equations. So let's do that. So in our previous video, we had already calculated sxy and sxx. So you can just substitute that back into this formula to get slope. Okay, so the slope for the linear regression line here is positive 4.0593. So class, if slope is positive, that means your variable has a positive correlation. Okay, dia memang synchronized. If slope is positive, that means the linear relationship is also positive. Okay, if slope is negative, so the linear relationship should also be negative. So if you can recall in our previous video, R is equals to positive 0.9448, right? So it has a positive, strong positive correlation. So that fact, okay, that interpretation is also same with this slope, because that one is positive and this is also positive. So that those two should come in line, okay? Dia kena sama. Okay, and then we need to calculate the intercept. So you need to find the average of data x and also average of data y. Okay, so yeah, average is the same formula for average that you learned before. Just total out all this value and divide by its sample size. That'll give you 10.25 for number of hours and 68.5 for final marks. And substitute all this into the intercept formula. So you have 26.8926. So this is your y-intercept. Okay, so then you need to write down the linear regression line. Oh my god, this is a mistake, class. Let me correct this. So this should be y hat. Okay, because when you use sample data to calculate or to construct the equation, you need to use notation y hat. Remember this. Okay, this should be y hat. Okay, right. So then so y hat equals to intercept dulu. Okay, intercept first, 26.8926 plus slope 4.0593 and also x. Don't forget to write down x beside the slope. So this is the linear regression line for to represent the linear relationship, to represent the strong positive linear relationship between independent variable and dependent variable here, which is number of hours and also the final marks. Okay tak tu? Alright, so this is how to calculate the linear regression line. Right, so in my next video, I will explain to you on how to interpret this slope and intercept value. Okay, so I'll see you in my next one. Bye.